Hello friends, this video is brought to you by www.moeteaching.com.
Let us read the question. Find the zeros of the quadratic polynomial and verify the relationship between the zeros and the coefficient. First thing that we need to do is to find the zeros of x square plus 7x plus 10. Let us split the middle term. Factors of 10 are 2 and 5, which can be arranged as 5 plus 2, since we need plus 7 in the center. So this can be written as plus 5x plus 2x plus 10, and solving further we get x plus 2 and x plus 5 as the two factors of this polynomial. Now to find the zeros, we equate x plus 2 equal to 0 or x plus 5 equal to 0. This gives us thus x equal to minus 2 and x equal to minus 5 are the zeros of this polynomial. Here notice that we are using OR while equating the factors equal to 0 because there is a product of two factors and product is 0 if any one of them is 0. So we write either x plus 2 equal to 0 or x plus 5 equal to 0 will make the polynomial equal to 0 and get the zeros of this polynomial. Next, we have to establish the relationship between the zeros and the coefficient. So let us start with sum of the zeros. It comes out to be minus 2 plus minus 5, which is equal to minus 7, and this can be written as minus 7 by 1, but 7 is the coefficient of x term. If we compare with general form ax square plus bx plus c, we have b equal to 7. So we can write this as minus b by a as a equal to 1. That is, we have established that sum of the zeros is equal to minus the coefficient of x by coefficient of x square. Similarly, let us establish the product of the zeros. It comes out to be minus 2 multiplied by minus 5, which is equal to 10, and which can be written as 10 by 1, that is equal to c by a, or we can say that product of the zeros is equal to constant term by coefficient of x square. Let us read the question. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. So let us start by finding the zeros of the polynomial x square minus 3. For that, we first factorize this. X square minus 3 can be written as x square minus root 3 whole square. This can be compared to a square minus b square equal to a minus b into a plus b. So the two factors are x minus root 3 into x plus root 3. Now the value of x square minus 3 will be 0 when x minus root 3 is 0 or x plus root 3 is 0. So that means x equal to root 3 or x equal to minus root 3, and finally we get root 3 and minus root 3 are the zeros of the polynomial x square minus 3. Now let us verify the relationship between the zeros and the coefficient. So we start with sum of the roots. It comes out to be root 3 plus minus root 3, which is same as root 3 minus root 3, which is equal to 0. If we compare the given quadratic polynomial with the general form, we can see the coefficient of x, that is b, is 0 in the given polynomial. So this can be written as b by, or we can say minus b by a, so which is equal to minus the coefficient of x by coefficient of x squared. Hence we have verified the relationship between coefficients and sum of the roots. Now let us verify product of the roots. It will be root 3 into minus root 3, which is equal to minus 3. Now on comparing the general form and the given polynomial, we have c equal to minus 3. So we have c by a, and we verify that product of the root equal to constant term by coefficient of x square. Let us read the question. Find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2 respectively. If alpha beta are the zeros of the required quadratic polynomial, then we are given that alpha plus beta equal to minus 3 and alpha beta is equal to 2. We know the formula for finding such a quadratic equation. We would like to elaborate that here k is a constant because there can be many such quadratic equations which can have sum of the roots minus 3 and product of the roots 2. And for different values of k, we can get different equations. So we have one such equation as x square minus 3 times x plus 2, which is equal to k times x square plus 3x plus 2. Now for different values of k, we can get different quadratic equations with sum of the roots minus 3 and product of the roots 2. For k equal to 1, one such equation would be fx equal to x square plus 3x plus 2. Let us read the question. Verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial, and then verify the relationship between the zeros and the coefficients. To verify if 3 minus 1 and minus 1 by 3 are the zeros of px, we simply need to find the value of px at these values and see if they come out to be 0. If p of 3 comes out to be 0, it is verified that 3 is the 0 of px. Similarly for the other numbers. So let us start with p of 3. It comes out to be 3 into 3 cube minus 5 into 3 square minus 11 into 3 plus 3, which is equal to 81 minus 45 minus 33 minus 3, and it comes out to be 0. So we have verified that 3 is the 0 of polynomial px. Similarly, let us find the value of px at x equal to minus 1. Again the value is 0. So we have verified that minus 1 is the 0 of the polynomial px. Now let us check for minus 1 by 3. Again the value of polynomial at minus 1 by 3 is 0. So we have verified that minus 1 by 3 is also the 0 of polynomial px. Now it remains to verify the relationship between the zeros and the coefficients. We have alpha, beta and gamma, and by comparing px with general form of the cubic polynomial, we have a equal to 3, b equal to minus 5, c equal to minus 11 and d equal to 3. We know that the following three formulas should hold, but we have to verify. So we will calculate alpha plus beta plus gamma and check if it is equal to minus b by a. Similarly, the other two expressions. We start with the verification and find alpha plus beta plus gamma equal to 3 plus minus 1 plus minus 1 by 3 gives us 2 minus 1 by 3, which is equal to 5 by 3. Now 5 is the coefficient of x square, but it is negative. So let us write 5 as minus of minus 5 whole by 3. Now minus of this can be compared to minus b by a. So we have verified that sum of the zeros of a cubic polynomial is minus b by a, that is minus the coefficient of x square by coefficient of x cube. Similarly, let us verify the other two. Alpha beta will be 3 into minus 1 plus beta gamma, that is minus 1 multiplied by minus 1 by 3 plus gamma alpha will be minus 1 by 3 multiplied by 3. Now let us solve this. We get minus 11 by 3, but minus 11 is the coefficient of x, which is same as c by a. So we have verified that product of the zeros taken two at a time is equal to c by a. Now let us verify alpha into beta into gamma. That will be 3 into minus 1 into minus 1 by 3. On solving we get 1. This can be written as 3 by 3 or minus of minus 3 by 3. Why we are doing this is because our d or the constant term is minus 3 in the equation. So we have reached the result that product of the root is minus d by a. Hence, we have verified that the relationship between the zeros and the coefficients hold for the given cubic polynomial.